Good morning. This video is about to make a model on projection of lines which is inclined to both HP as well as VP. With that model, you will be understanding the concept of projection of lines inclined to both HP as well as VP. Let us go through the problem statement. So this is the problem on projections of a straight line inclined to both VP and HP. So this is the model you are going to make. To make this model, we will be explaining you the complete concept with the help of drawing. We also will be showing you how to make this model. The problem is the distance between the end projectors of a line AB which is inclined to both HP and VP is 80 mm. Point A is 40 mm above HP and 40 mm in front of VP. Point B is 120 mm above HP and 80 mm in front of VP. Draw the projections of the line. That means we have to draw the front view and top view of the line and find the true length of the line AB and determine the angle the line makes with HP and VP. Draw the traces also. So this is the model and this is my point A, this is my point B. So this point A is in space which is 40 mm in front of VP and 40 mm above HP. This is my point B which is 80 mm in front of VP and 120 mm above HP. So for this line in space, this will be my true length. For this line in space, this will be my top view. So now we will see how to draw and how to make the model. Today we will be solving a problem on projection of line which is inclined to both HP as well as VP. So the problem statement we have seen, we have two end projectors. So the end projectors distance between A and the distance between projector B is 80 mm. So distance between end projectors is given as 80 mm. So what we do is, we will be drawing a line XY, then we will be drawing a vertical line. I hope that you can see this vertical line. You can draw this line anywhere and draw another vertical line at a distance of 80 mm from the first vertical line. So that means on the first vertical line we will be having the front view and top view of the point A. In the another vertical line we will be having the front view and top view of the point B. So this is one statement of the problem. Distance between end projectors A and B is given as 80 mm. Next, the point A is 40 mm above HP. So you can see here from XY line on the projector line of A, locate the point A dash which is 40 mm above HP. Then point A is 40 mm in front of VP. So from XY line at the downward direction, locate 40 mm, that will be the top view of the point A. So we have drawn XY line, we have drawn first vertical line on which we will be having the front view and top view of A. We have drawn another vertical line at a distance of 80 mm and on which we will be having the front view and the top view of the point B. So point A is 40 mm above HP. So on the first vertical line we have located A dash which is 40 above HP. we located the top view of point A, which is 40 mm below XY line. Likewise, the point B is 80 mm in front of VP and 120 mm above HP. So here the point B on the second projector, locate a point B which is 80 mm in front of VP, that is below XY line, and the point B is 120 mm above HP. So the same projector, locate point B dash which is 120 mm above HP. So that means we have located the points A dash, B dash. Now we can join A dash with B dash, so this will represent the front view of the line. Likewise, we have located the point A, we have located the point B, join AB, that will represent the top view of the line. So we have drawn the front view of the line AB as well as we have drawn the top view of the line AB. So this completes the 50% of problem. Now we have to find out what is the true length of the line AB. We have to also find out what the line AB makes with respect to HP as well as what the line AB which makes with respect to VP also. Now we will see how to find out. Now here we have a beautiful model in fact. So this is the whole model, a wireframe model. So now again I repeat the problem here. This is the point A in space, this is the point B in space. So the point A is 40 mm in front of VP, 40 above HP. Distance between these projectors A and B is 80 mm and point B is 80 mm in front of VP, 120 above HP. So this is my line AB. So this line AB is inclined to both HP as well as VP. Now I want to find out what is the true length of AB. Kindly carefully see what I am doing is, so this is a trapezium. I have drawn this, I have made this trapezium separately here. I hope you can see it. So this is how the line is. Now what I do is, to find out the true length of line AB, I am making the line AB parallel to VP. Kindly carefully see what I do is, I make the line AB which is inclined to VP, I make it parallel to VP. So this process, say the point A is fixed, the point B is here, so I move it like this. By this movement, this point B will be at the same height with respect to HP. The height of B is not changed. And again you can look carefully, the top view of the line AB again will remain the same. So this is an important concept. When a line is making an angle theta with respect to HP, whatever may be the angle the line makes with respect to VP, its top view length will remain same and the distance or the height of the point B also will remain the same. I hope it is clear now in the model. Then using this concept, what I do is, we will come back to the drawing now. So what I do is, this is my top view of the line. So with A as center, AB as radius, I draw an arc so that I am making this top view parallel to VP. I am getting the point B1. So now I had this point A here, I had this point B here. Now what I do is, I fix the point A, I move this point B like this, so that this distance remains same and I make it parallel to VP. So by making it parallel to VP, I am moving this point B to a new point, I call this point as B1. So, with A as center, AB as radius, I am drawing an arc so that this line AB1 is parallel to XY line. So, top view length remains same. The same concept, if you observe the point B, by moving like this, the height will remain same. So, I got this point B dash here. From B dash you draw a horizontal line. That means the B will be of the same height whenever the angle theta remains constant. So, from B dash I am drawing a horizontal line, and from B1 I am drawing a vertical line. The intersecting point will be called as B1 dash. Now, if I join this A dash with B1 dash, I will be getting the true length of the line. So, now I cannot see the true length. If I make it parallel, I can see the true length here. I can see the angle theta also, what this line makes with respect to HP. So, this will be my angle theta, and this is my true length. Now, I want to find out the angle the line makes with respect to VP. So, what I do is, I have another model here. So, the line was like this. So, this was my point A, this was my point B. Now, what I do is, I make the line parallel to VP. Can you observe carefully? This is my point A, this is my point B. By making this line like this will be my front view length, that will remain same. At the same time, the point B with respect to VP will make the same distance. Kindly observe carefully. The point B with respect to VP will maintain the same distance, and the front view length will remain same. Whatever the angle the line makes with respect to HP, as long as the line makes same angle with respect to VP. Now, we will see how it is done in drawing. So, with A dash as center, A dash B dash as radius, I am drawing an arc so that I make this line parallel. So, this point I call it as B2 dash. So, A dash B2 dash will be the front view line when the line is parallel to HP. So, now the point B will maintain same distance with respect to VP. So, from B I am drawing a horizontal line. So, from B2 dash if you draw a vertical line, that will be intersecting the line drawn, horizontal line drawn through B, intersecting point will be B2. Now, if you join A with B2, that also will be giving the same true length, and if I measure the angle AB2 makes with respect to XY line, I will be getting the angle the line makes with respect to VP. So, I have found out the true length, I found out the line, the angle makes the line with respect to HP, I also find out the angle the line makes with respect to VP. Now, what we do is, we have to find out the traces. To find out the traces, what I do is, I extend the line A dash B dash to cut the XY line. The intersecting point will be H dash. That is the front view of the horizontal trace, because horizontal trace is a point which lies on HP. The intersecting of the line with respect to HP is called as horizontal trace. So, I extend this front view of the line to cut the XY line at the point H dash. From there, I am dropping a vertical line, and the top view of the line AB, I am projecting it here. This AB projected will be cutting the vertical drawn through H dash. The intersecting point will be H, that is horizontal trace. Likewise, to find out the vertical trace, I extend the top view of the line to cut XY line. You will be getting V, that is the top view of the vertical trace. From there you drop a vertical. So, this vertical will be cut the front view extended at the point B dash. So, V dash and H dash are called as traces of the line. Now, I can show the model in 3D. So, this is my point A, this is my point B, this will be my front view, and this is my top view of the line, and this is the angle the line makes with respect to HP, and this is the angle the line makes with respect to VP. So, this is a wire frame model. The same model, instead of wire frame, I made this as a solid model. Now, you can see this is the point A, this is the point B, and this point A is 40 in front of VP, 40 above HP. So, this is my point B. The point B is 80 mm in front of VP and 120 above HP. So, the distance between the projectors A and B is 80 mm. That is this distance, that is 80 mm. Now, this is a solid model. Now, what I do is, with the help of the solid model, then I can find out what is the angle theta and what is the angle phi. Now, what I do is, this is my trapezium. Now, I make this trapezium parallel to VP like this. Now, I can find out the true length here. I can find out the true angle also. Likewise, if I have a trapezium like this in the top view, I can make this parallel to VP, so that I can find out the true length. I can also find out what is the angle the line makes with respect to VP. So, once you make this model, you can understand very easily. What I have done here is, so I have got the true length, I got the angle theta, I got the true length here also, I have got the angle phi. Now, if you want to make the model yourself, that is the main objective, what you do is, from the point A dash to the line A dash B dash, you draw two vertical lines. So, you take the distance of 40 mm and measure here. On the another vertical drawn through B dash, you draw for a length of say 80 mm. So, I repeat again, I have the front view line A dash B dash. To this line, you draw two perpendicular lines through A dash as well as through B dash. Through A dash, you measure a length of 40 mm. From B dash, you measure a length of 80 mm on the vertical lines. So, this will be the point A, this will be the point B. So, now you will be getting a trapezium. Likewise, in the top view, I have the top view AB. So, to this line, you draw perpendicular lines through A as well as B. On the vertical line drawn through A, you measure a distance of 40 mm. On the vertical line drawn through B, you measure a distance of 120 mm. So, I will be getting this point A here, I will be getting the point B here. So, I got a trapezium here, I got a trapezium here also. Now, to make the model as we have made here, what you can do is, you can fold it like this, then you can fold it like this. The next I will be folding it so that the whole HP is made. I hope that let me remove this. So, this is how the model will be making it. So, you will be making HP like this, and this is the trapezium which will be like this, and this will be trapezium which will be vertical, and now you can see this will be point B, this will be point A. So, this will be my top view, this will be my front view. So, I request all the students to make this model so that you can understand the concept of the line inclined to both HP and VP. So, this will be my angle theta and this will be my angle phi. So, model making is very important, and see that you are understanding the concept of true length, true angle with respect to HP, that is this angle, and the true angle the line makes with respect to VP, that is angle phi. So, kindly make this model, and once you make this model you can join these two. So, this represents the line inclined to both HPS plus VP. So, this is my point A, this is my point B. This is my A dash, this is my B dash. This will be point A, this is point B. I hope the model making is clear. If you make the model yourself, you will be getting the model like this. So, if you make a model like this, that will be the end of this project. Thank you very much. Thank you.